In the first video, we named ionic compounds, in which we know by now an ionic compound is a compound with a metal and a nonmetal. But in the first series of videos, we only dealt with metals that were from these first two families, the alkali metals and the alkaline earth metals. And then we did all the nonmetal anions, and they came from obviously the nonmetals over here. Now, today we're going to take this a step further. We're going to start naming compounds that include transition metals, which is this region on the periodic table. And the thing about transition metals that makes them a little bit different than other metals is that they can form more than one cation. At least several of them can. For example, if we were going to name the compound iron oxide, we might, or I'm sorry, if we're going to write the formula for iron oxide, we might write FeO. Okay, well, that could be iron oxide. But we might also write Fe2O3. Now, what's the difference in these? Well, in this first scenario, the iron has a 2 plus charge, and in the second scenario, the iron has a 3 plus charge, because oxide is always a 2 minus. So in this case, 2 minus means the iron must be plus 2. And here, if we've got 3 at negative 2, that's negative 6. And then if we've got positive 6 from the iron, there are 2 iron ions present. Each one must be plus 3. So remember, a good name had to do two things. It had to tell, what types of atoms we had, for example, iron and oxygen, and then how many of each one. So this name doesn't work because it leaves some ambiguity. We're not sure, is it FeO or is it Fe2O3? So what we need to do to solve that is we need to add another rule. And the rules stay the same for anions, which is good, but we add this rule. If the metal can form different cations, the positive charge is indicated in parentheses following the metal. So this would be iron 2 oxide. And the next one down here would be iron Roman numeral 3 oxide. And now we can see that these are fitting names because they tell me the number and types of atoms that are present in these compounds. So anytime we're naming a transition metal ion, we need to indicate the charge in Roman numerals. So let's go down and work some examples here. So in this first scenario, we're going to go from formula to name, and I think it's helpful to write the cation and the anion. So here we go. We know that the anion in this case is oxide, which is a 2 negative charge, because oxide is always a 2 negative charge, because if we scroll back up, it's in this family right here, right? Maybe negative 3, negative 2, negative 1. So oxygen's right there, negative 2. Okay? And then in this case, if we've got 2 at negative 2, the titanium must be a 4 plus. So the name would be titanium, Roman numeral 4, parentheses, oxide. Okay? Now, let's look at this next one. In this case, we have a fluoride anion, which is a -1, because that's the family that it's in. And then we have vanadium, and since there's 2 fluorides here, right, there's 2 of them, that's like 2 at negative 2, 2 at negative 1, meaning that this has to be V2 plus, which is going to be vanadium, Roman numeral 2, fluoride. Okay, why don't you go ahead and try the rest in this table, and go ahead and hit pause and see how you do, and then check your answers. All right, so I've displayed the answers down here, and let's just check in here and see how we did. So in this case, we know chloride is a -1. That means the cobalt has to be a 3 plus. So that would make the name cobalt 3 chloride. Down here, the sulfide is a 2 negative. We know that from the periodic table. So then we would go back, work backwards and say, okay, 3 at negative 2 is negative 6. So we must have positive 6, but each copper is going to have positive 3 because there's 2 of them. So we're going to get Cu3 plus, and that becomes the correct answer, copper 3 sulfide. Now down here we have iodide with a -1 charge, okay? Because it's, like I said, if you're curious where I'm getting these, let me just go back real quick. Iodide's right here, so that means a -1 since it's a halogen. Go back down, and then I get SN2 plus, and I get tin 2 iodide. And then finally, down here, chromium 2 sulfide. So again, I'm going to do chromium, or I'm going to do sulfide, which is a 2 negative, and then the chromium, which in this case is going to be a 2 positive, and there's the answer. Now I want to point something out. A lot of times the misconception is that when you see these Roman numerals, people tend to say, chromium 2 sulfide, so they go Cr2S, okay? But that's something that's very important that we don't get in that habit, because that is not what we want to do. This Roman numeral, remember, is the charge on the metal ion, okay? It has nothing to do with the number of atoms present. We figure out the formula here based on the fact that of charge balance, because an ionic compound has to be neutral. So for example, in this case, since sulfide is 2 minus, the chromium has to be 2 plus. All right, let's go down and try a little bit of review here. So I'm going to pick a couple of these out. We'll start off with the first one. So this first one, we're given aluminum bromide, okay? Well, we go back up and we look at these. We found aluminum is right here in the periodic table, and bromide is right over here. Well, aluminum's actually a +3, and it's always going to be a +3. So in that case, we actually don't need Roman numerals. That's why you don't see Roman numerals here. And the cation is going to be Al3 plus, and the anion will be Br minus. So the formula here is going to be Al Br 3 in this case. Aluminum's a 3 plus, bromide is a minus charge, so AlBr 3. Now in this case we have a Roman numeral, so we know that our cation is going to be copper with a 2 plus charge. And if we go back to the periodic table, we'll see sulfide is a 2 negative charge, so we end up with CuS. All right, now let's jump down here where we're going from a formula to a name. So in this case, we know that oxide is a 2 negative charge, because it always is, well, unless it's a peroxide, but we'll talk about that in a later lesson. And then the titanium, since this has to be neutral, the titanium must be Ti2 plus. So if I want to know what my answer is in this one, it's got to be titanium 2 oxide. Titanium Roman numeral 2 oxide, because that's the charge on the titanium ion. Okay, you guys go ahead and finish up, and then we'll check our answers. So click pause and see how you do. Okay, so here are our answers. In this case, we've got gallium sulfide. All right. Why do we not have a Roman numeral? Well, because gallium's going to be a +3. It's in that family, the same family as aluminum. And so in this case, the gallium is going to be a 3 plus. S is a 2 minus. And therefore, we're going to need 2 galliums and 3 sulfides. That's +6, -6. Everything balances out. Okay, down here, rubidium phosphide, P3 minus. And in this case, we don't have Roman numerals. Oh, and that makes sense because rubidium is an alkali metal. So it's going to be a +1 charge. So that one just goes, that's why we don't have any Roman numerals there. Rb plus was the cation in this case. Now, the name here was rhodium 2 fluoride. So this is the formula. And we got that because fluoride is a -1. Right? That must make the rhodium +2. And then down here, cesium chloride. Cesium is an alkali metal, so there's no Roman numeral. It's going to be a +1. And chromium 3 oxide, that means we've got chromium with a 3 plus charge and oxide with a -2 charge. So we're going to have 3 oxides and 2 chromiums to make -6 and +6. And then lithium nitrate, Li with a plus, and N3 minus, lithium nitride. Okay, no Roman numerals because this is another alkali metal. So we know that it's a +1 charge, and nitride we know is a negative charge from the periodic table.